Many, yeah, more than 2 steps. So we're not limited to just 1 and 2 step equations anymore. We have more than those 2 steps. And honestly, you could have an equation that requires 10 different steps or more. We won't have that crazy of problems, but we will have more than just 1 or 2 steps. All right, so the steps for solving equations is essentially the same. We're going to go ahead and review that here. So our 5 steps to solve an equation. Our first thing what we want to do is get rid of parentheses. Right, get rid of parentheses. This often requires you to distribute, so you might want to put a note there of distribute. And there's actually a way we can solve without having to distribute. I'll show you an example of that today. But sometimes it's easiest to go ahead and distribute it out, so we don't have to deal with parentheses anymore. All right, our second step, and honestly, you might not have parentheses, you might jump to step 2, but our second step is to combine like terms on each side of the equation. So combine like terms. And again, if you're struggling with what like terms are, you need to come get help with that because that is not going away. In fact, that's going to be in pretty much every single lesson we do from here on out. And it's also in geometry and also in algebra too. So make sure you're understanding combining like terms. Remember, we do this on the left side, and we do it on the right side. Right side. Now, once we've combined like terms on each individual side, then we want to start moving things around because we want to get the variable by itself. So we want to get variables on one side and everything else on the other side. And that's our third step, is to get variables on one side. Get only variables on one side. Right, get only variables on one side. So variables on one side, everything else on the other. Our constants, the numbers without variables, those are called constants on the other side. And remember our last 2 steps, we have to do PEMDAS backwards. So we need to first get rid of addition and subtraction. Rid of addition and subtraction. And then we can get rid of multiplication and division. All right? And remember, we need to be very careful that we don't forget we have to do the same thing to both sides. And that's pretty much for these last 3 steps here. All right, so again, it's the same steps as before, but now you might have to do some of that distributing. Remember, we can always check our work by substituting it back in. By substituting in the answer. Because if it's a solution, it will make a true statement. Right? If it's not a solution, meaning that we did something wrong, then it will make it not a true statement. You might get something like 2 = 9, which is not a true statement. You with us? Good? Alright, so again, this is just like last class, there's just more steps. So we're going to go ahead and just make our way through these problems. I want to get through a lot of different problems so you can see the different types we might encounter. Alright, so let's take a look at our first one. We don't have any parentheses here, so we can go ahead and skip that first step. Our second step says to combine like terms. So we want to combine any like terms we have on the left side and then combine any like terms we have on the right side. What like terms do we see on the left side? Okay, Sean, what's 2 that we can combine together? What are 2 that we can combine together? Negative 9x is one of them. Good. Good. And positive 2x. What else can we combine with negative 9x and positive 2x? Very good, Trinity. X. And notice I'm including those signs with it. So positive 1x, positive 2x, negative 9x. Okay. So let's take a look at our other like terms. On the left side, we also have negative 4 and positive 7 can be combined together. This is something that you guys were struggling with on your test, so make sure you're paying attention to this part here, especially if you're struggling with that on the test. Again, it's very helpful to draw boxes, circles, underline, cross it off, highlight it, whatever you need to do to help you separate them. All right, so let's combine our x's together first. We have negative 9 plus 2 plus 1. What is negative 9 plus 2 give us? Negative 7, good. So these are negative 7, and then negative 7 plus 1, what does that give us? Very good, negative 6. Right, and I like to go ahead and cross these out as I've taken care of it. So you make sure you don't forget any terms there. All right, so all 3 of those like terms combine together for negative 6x. Okay, so then we have negative 4 and positive 7. What does negative 4 and positive 7 give us? Good, positive 3. And remember, this is the same thing as subtracting. 7 minus 4, which is 3. Okay? And then we still have negative 15 on the right side. There is nothing to combine over here, so just curious. Notice that now we don't have like terms to be combined together, so we can solve it just like we did last class. This is now a much more simpler problem. All right, Trey, what do you think is going to be our next step here? Very good. We're going to subtract our 3. Remember, we want to do our addition and subtraction first, if possible, before our multiplication addition. So we have the negative 6x. Positive 3, negative 3 cancel each other out. Trey, please stop distracting. And then we have negative 15 minus 3. Mohammed, what does that give us? Negative 15 minus 3. Close, very close. Notice that they're both negative. Good, negative 18. Remember, you can use your calculator to help you out too if you need to. So again, they're both negative, so it's the same thing as adding them together and then negative terms. All right, anybody want to volunteer for the next step? Divide by negative 6, very good. And notice we have to do this to both sides. Negative 6 divided by negative 6 is just 1, so we have 1x, or you can just write x. What's negative 8 divided by, or negative 18 divided by negative 6? Very good, positive 3. And this is our answer here. Anybody remember how to write that in set builder notation?
What?
Good, we have a curly brace, x, and what do we do? Vertical line, x, equals 3, very good. So those of you that weren't here last class, this is just another way of writing our answers called set builder notation. It's something that you use more in Algebra 2, so we introduce it now. This is just simply saying x's are variable, so any x's that have the following properties, x equals 3. So really all you do is say your variable, vertical line, and then your answer. Very good. So notice this great big complicated problem, after combining those like terms, became to be something not so bad. Questions on that? All right, I'm going to show you 2 different ways to do number 2. Because we can go ahead and distribute this out, or we could actually use division. So I'll show you both and then let you decide which one you like better. So according to our instructions here, the first thing says to get rid of the parentheses, which often means to distribute. And if we go ahead and distribute this, remember it's 5 times n minus 3. So we do 5 times m, which is 5m, And 5 times negative 3, which is negative 15, equals negative 10. And then again, this is just like a problem we had last class. Giovanna, do you have an idea of what we would do next? Do you have an idea of what our next step would be? Give a guess. It's okay. I'll make Nauman help out afterwards, so it's okay. Just give it your best guess. Look at what we did over here. We subtracted our 3, and then we divide by the negative 6. What do you think we should do over here? I hear whispers. That's okay. Let's take a look at our steps. We've already combined like terms. We're trying to get so that just the variable is on this side. So we need to get rid of addition and subtraction first. Do you see any addition or subtraction here? Are we adding anything within our equation? No. Are we subtracting anything? What are we subtracting? Yeah, we're doing 5m minus 15, right? So we need to do the opposite of that to get rid of it. So Tayshawn, what do we do then? If we're currently subtracting 15, we need to do the opposite. What's the opposite of subtracting? Okay, so we need to add the 15 to both sides. So now I'm going to use you here. What do we get with negative 10 plus 15? Very good, positive. Okay, so then if you want, what's our next step here? Very good, we have to divide by 5. Again, we're currently multiplying, so we have to do the opposite, or the inverse operation. We have to do it to both sides. So we have to get here. And that's your answer there. Now I want to show you another way of going about doing this. Alright? We start off with 5 times m minus 3 equals negative 10. So we'll go ahead and set this here for you. Okay. Instead of distributing, we can actually divide to get rid of my 5, because we're doing 5 times the parentheses n minus 3. So the opposite of multiplying is dividing. So divide by 5 on both sides. 5 divided by 5 cancels out, so we're left with just n minus 3. What does negative 10 divided by 5 give us? Very good, negative 2. And then now all I have to do is add 3. So we have m equals negative 2 plus 3 is positive 1. Notice we arrive at the same solution. Either way works. Sometimes it's a little bit easier to do it the left side. Sometimes it's a little bit easier to do it the right side. So I just want to show you both of that. Any questions on that? Alright, so Bryn, you with us?
I love it when people are awake in my class.
Good morning, sunshine! Alright, let's take a look at the next problem. So here we have negative 4p minus 2 times 4 plus p equals 2. And you'll notice we're start throwing in the fractions here, alright? So you need to be careful with number 4 when we distribute that. If you need to use your calculator to help you out, great, go ahead and do so. Alright, number 3. We need to first distribute my negative 2. Because it said to get rid of parentheses, so we're going to first distribute it to get rid of it. Alright. Now remember, this is the same thing as plus and negative. So when we're multiplying negative 2 to each piece. Alright, so negative 4p. Negative 2 times 4 is negative 8. Negative 2 times p is negative 2p. Equals 2. Alright, so now we need to combine our like terms. Alex, what can I combine together here? Negative 4p, and what else? Good, and negative 2p. So negative 4p, negative 2p, that gives me negative 6p. And I still have my minus 8. I couldn't combine that yet with anything. There's nothing on the left side that I can combine with. Equals 2. Right, questions so far? Okay. So now we want to try to get our p by itself. So let's add 8 to both sides. Because we want to do addition or subtraction first. I like to think of it as what's easiest to get rid of. It's easier to do the addition subtraction. Right? Those cancel. So I have negative 6p equals 10. Again, we need to have the variable by itself. There's still that negative 6 within to be multiplied. So, Antonio, what do you think we'll do next? Very good. Divide by negative 6. Again, those cancel. Negative 6 divided by negative 6 reduces down to 1. So I have p equals, and negative 10, 6 we can actually reduce. So negative 10, 6, but we can reduce this. You can use your calculator, or we can look and see if they are both divisible by 2. So negative 10 divided by 2 is negative 5. And then 6 divided by 2 is 3. So we have p equals negative 5 times. And that's our answer there. Any questions with that one? Okay. Let's take a look at number 4. Again, we're dealing with fractions, so sometimes it's easier to distribute it, sometimes it's easier to go ahead and get rid of it. Does anyone remember? So we're currently multiplying right here, right? What is the inverse operation, or the opposite of multiplying? Dividing. So technically, we would divide by 2/3, but that looks pretty ugly, right? Dividing by a fraction. We have a number over a fraction. Does anyone remember what we can do instead of dividing by 2/3? Instead of dividing by a fraction, we can multiply by what? Close, close. Multiply by 3 over 2, right. Anybody remember what that's called? Very good, the reciprocal. Alright, so again, I'll show you both ways to do this here. But instead of dividing by 2/3, we can multiply by the reciprocal. The reciprocal is simply taking this and flipping it. So the 3 is in my numerator, the 2 is in my denominator. Alright, so 3 times 2 is 6. 2 times 3 is 6. 6 divided by 6 is 1. So these reduce. So I'm left with just 6m minus 15. And then here, this is negative 16 over 1. So this reduces as well. These each reduce by 2. So that'd be negative 8. So negative 8 times 3, which is negative 24. Right. And again, you can use your calculator to help out those fractions. Alright, so now let's again back down to either a 1 or 2 step equation like we did last class. So I'm going to add my 15. Those cancel, so I have 6m equals, and this one's a little trickier, negative 24 plus 15. Anybody know what that one is? Very good, negative 9. And then Gloria, what do you think our last step is going to be? Take a look over here. When we had negative 6p, right, we have to divide because it's 6 times m. The opposite is to divide. So those cancel. And again, this fraction here can reduce. Make sure you're always giving your answer to us in simplified form. If you need to, use your calculator. I'll leave you to it. Okay, remember in your calculator you can just simply type in -9 divided by 6. It'll give you a decimal, and how do we change that back to a fraction? Right, math 1. So hit the math button, and then hit 1, which says fraction, or F-R-A-C. Okay. And that'll convert it to its simplified form, which would be -3/2. Questions on that one? Okay. I want to show you how to do it with distributing. I'll pull that back up there. I want to show you how to do this with distributing. Okay, so starting off with our equation, 2/3 times the quantity 6m minus 15 equals -6. This first way I showed you how we can multiply by the reciprocal, but again, remember we could also just distribute it. So I want to show you that. So distribute your 2/3 to the 6m. 2 times 6 is 12, divided by 3 is 4, so that's 4m. Again, you can use your calculator to help you with those fractions. 2/3 times -15. 2 times -15 is -30, divided by 3 is -10. Okay, so again, notice with this one, the fractions reduced nicely into whole numbers. Then add our 10. So I get 4n equals -6. And then divide by 4. And we get n equals, and this again reduces down to -3/2. Alright, so notice that's another way to do that, where you can distribute it there. Let me move this down. Ah. Alright, so again, you can distribute out that fraction, or you can multiply by the reciprocal. Whichever one's easiest for you. Okay. Questions on that? Alright. Let's take a look at 5 and 6, and then I'll let you try some on your own. Okay. Again, we have parentheses here. We need to get rid of it. What are we going to do with that? Alex? What are we going to do to get rid of these parentheses here? Distribute, right. We have this negative. You can think of that as -1. We're going to distribute that to both pieces. So again, 7y. -1 times 4 is -4y. A lot of you were losing your variables, or some of you tried combining this together. You have to distribute that first. And then -1 times -1, +1. Okay. Abdul, do you want to give a try for the next step? No? Don't feel comfortable with it? Okay. Rachel, what do you think? Yeah, we're going to combine our 7 and our -4 together. These are like terms here. So I'm going to combine 7y, -4y, and then 1 is all by itself. Alright, so 7 and -4, 3y, plus 1 is equal to -4. Now this is just like what we did last class. Rachel, what do you think we'll do next? Very good, subtract 1. This cancels, so -12 minus 1, -13. And then Morgan, what do you think our last step is? Divide by 3. And this gives us a not very nice fraction. Those reduce to 1, and you can't reduce -13/3 anymore. So anyway, take a look at number 6. This is a different kind. In which, look, we now have more than just one thing on the right side. We have variables and constants on the left side, and variables and constants on the right side. Again, remember, a variable is this letter that represents a number, and a constant is a number that has no variable with it. So those two are my constants. Okay. So there are no parentheses to get rid of. There are no like terms on the left side that we can combine, and no like terms on the right side that we can combine together. Our end goal is to try to get the x by itself. So we need to go ahead and combine our x values together. But remember, when we cross this equal sign, we have to do the opposite operation. Now, you could either subtract 3x over or add 5x over. Either one works. I prefer to add the 5x over so that it's already a positive variable, right? So I prefer to go ahead and add this over because then I'm going to have positive 8x. If I were to have subtracted my 3x over, I'd have negative 8x. We will arrive at the same answer, but then you have to deal with a negative. And I prefer to go make it positive if I can. Okay? So then it's again back to how we had it last class. Add your 2. 8x equals 8. Divide by 8. Those reduce, and x equals 1. And again, in set notation, x such that x equals 1. Curly brace, curly brace. Any questions on that one? Same idea, just combining like terms. Notice we can substitute our 1 back in. We can substitute 1 in for x and check to see that it's true. So if I did that, I have 3 times 1 minus 2. Does this equal negative 5 times 1 plus 6? We've done this before where we were checking to see if something was a solution. Well, now we're checking our own answer to see if it is a solution. No, this is called set builder notation. I was just reminding you of what that is. I could do set builder notation over here. Y such that y equals negative 13/3. You can do set builder notation for every answer. I just did it here just to remind you of what it was. Yeah, good question. Okay, so I'm checking to see if 1 is a solution. Remember, when we're checking, we cannot cross or equal. So 3 times 1 is 3, minus 2. And 3 minus 2 is 1. Negative 5 times 1 is negative 5, plus 6. And negative 5 plus 6 is 1. 1 does indeed equal 1, so we know that this is a solution. That's something that's good to do on quizzes and tests to make sure you're doing the right thing. If you get that they're not equal, that means that you made a mistake somewhere and you double check your work. Alright, questions on that? Okay. Wait, yes? Oh, you're just not finishing off. Right, I want you to go ahead and try number 7 and 8 on the bottom of your worksheet there. Go ahead and try number 7 and 8. And once you get that, try 9 and 10 on the back side. It requires a bit of work. You're good? Thank you. So I want you to try 7 and 8. When you think you have those, check it with the person next to you, and then give numbers 9 and 10 a try. I'll give you a hint for 10. You're going to need to distribute on both sides. You're going to distribute on both sides. So give those a try and see what we can get. Alright, number 7. Again, we have variables and constant on both sides. So we need to get variables on one side, constants on the other. I'm going to add my W, again, just to keep it positive. You could subtract your 6 if you prefer. But I'm going to add my W. Remember, same thing as 1W. So I have 10 minus W plus W, that cancels out. So that's no longer there. 6w plus 1w is 7w. And then minus 25. Now it's just like what we did last time. Alright, I need to get w by itself, so I'm going to add 25. Add 25. So that's 35 equals 7w, and those end up canceling each other out. What try? Oh, you're good. That's one out. Alright, and then our last step, need to get w by itself still. We're currently multiplying, so I need to divide to get rid of it on both sides. 35 divided by 7 is 5. 7 divided by 7 reduces to 1. We have just w there. And our answer is 5 equals w, or w equals 5. Yes? I actually prefer that. Yeah, that's right. If you have w equals 5, that is also correct. In fact, I prefer it this way. Good. Do you guys have questions? Oreos are delicious, but that's not math right now. We talk about Oreos in algebra 2. Okay, number 8. Same idea. We need to combine our like terms. Here, both of these are negative. I'm going to add my 4a because that will result in having a positive variable here. Negative 2a plus 4a is positive 2a. If I added my 2a, I would have gotten negative 2a, which is fine on the right side. You still arrive at the same answer. So negative 2a plus 4a is positive 2a. Do you have a question? We're good? Plus 1. And then negative 4a plus 4a cancels each other out. And we have just 16 left. So now it's just like yesterday. Or Thursday. Subtract my 1. 2a. Those cancel. 16 minus 1 is 15. Then divide by 2. A is equal to 15 halves. And that's my answer there. Questions on 7 or 8? Okay. Take a look at 9 and 10. Here, again, I'm going to want to go ahead and distribute that negative 2. And notice I'm distributing this entire thing. So I distribute to D and to 3. So negative 2D. Negative 2 times 3 is negative 6. 1 minus D. Again, I want to move my terms to the same side. I'm going to add my 2D because that's going to give me a positive D. Okay. So negative 2D plus 2D, those cancel. So I have negative 6. So I have 1. Negative 1D plus 2D is actually just 1D or plus D. Alright, and then my final step, subtract 1 from both sides. Negative 6 minus 1 is negative 7. 1 minus 1 cancels out, that equals 0. And then we have just D. So D equals negative 7. And again, it's better to write it this way. Questions on number 9? Okay, so then number 10 requires us to do distributing on both sides. So I distribute my 3 to the x, so that's 3x, and 3 times negative 2, which is negative 6. On the right side, I have 5 times x, which is 5x, and 5 times 8, which is 40. Now it looks just like the problems above it. Here, I think I'm going to subtract my 3x, because again, that gives me a positive value here. So 3x minus 3x is 0, so that cancels out. So I have left negative 6. 5x minus 3x, they are like terms, so 5 minus 3 is 2x plus 40. Now you might think to yourself, well, let's add my 6 so that it's a positive value. but then you end up having to subtract it over anyways, because we want to get the x by itself on one side. So I'm going to go ahead and subtract my 40, and we're going to end up with a negative number. It just happens. So negative 6 minus 40, negative 46, equals 2x. Positive 40 minus 40 cancels each other out. So that's 0. Great. And then my last step, divide by 2. So then negative 46 divided by 2, negative 23. 2 divided by 2 reduces to 1, so it's 1x or just x. And again, x equals negative 23. Questions on that? Okay, so make sure you take a look at the next page. We talked about our properties a couple classes ago. There's some multiple choice problems. We talked about our properties, and this last page is just requiring you to state what property allows you to do this. All right, so so when they start off, the first step is always just given. It's what they gave to us. Now here, we subtracted 4x from both sides. And so that's our subtraction property of equality. And then, again here, we divided by 2 on both sides. So that's our division property of equality. And then here, 6 equals x, the same thing as x equals 6. That's our symmetric property. Right? So that's just combining what we've learned before with what we're doing this class. Any questions on that? It's just labeling what we've done. Alright, I'm going to go and pass out your homework to you. Remember, if you did not finish worksheet 1, that's also part of your homework. So we're checking worksheet 8 and worksheet 1 for next class. Worksheet 8 and worksheet 1 are due next class. No, it's due Wednesday. Next class.
To whoever is on your schedule, the screen on your screen, comes to me, Margaret,